So this video is going to go over a titration problem, what we call a three-step problem to do these. And this will be the format for pretty much everything else. There's some shortened ways you could do it, but this is kind of the way we set it up. So you're always going to be given an acid and a base. So I have sulfuric acid and I have base, sodium hydroxide. Okay. For each one of these types of problems, you're going to be given 3 bits of information and 1 bit of information you're trying to solve for. So in this case, our unknown is the molarity of sodium hydroxide. So sulfuric acid is reacting with sodium hydroxide. So the first thing you must do is write a balanced chemical equation. Does it matter which one you write first? No, it doesn't. So I'm going to write H2SO4 plus my sodium hydroxide, arrow pointing in one direction. I would always suggest you write water down first because we always know this is a neutralization reaction. And then sodium is a +1 charge. SO4, because it's attached to 2 H's, is a -2 charge. That means Na2SO4 is my ionic compound, So then balancing, again, you just normally balance, but you could also balance according to H's and OH. So I have 2 H's, so I need 2 OH's to neutralize it. And if I have 2 H's and 2 OH's, I have 2 waters. That's my balanced chemical equation. So whatever one you have 2 bits of information, so I have 2 bits of information of the molarity and the milliliters of sulfuric acid is always going to be what you start with. So in this case, it is the acid. The acid is the one that we have 2 bits of information. Remember that 1,000 milliliters is equal to 1 liter. So you will have to convert these milliliters into liters. So I'm going to start with my molarity. Okay, my molarity again is moles over liters. And so I have 2 moles per liter. So I'm going to write it that way in my formula. So 2 moles per liter. Now I'm going to set this up a little differently than proportions. I'm going to multiply it by the liters, because if I multiply it by the liters, I will then be left with moles because liters is on the bottom here. So 27 milliliters. So 27 milliliters is how many liters if I know 1,000 milliliters is equal to 1 liter. So what I'm doing is dividing the 27 by 1,000, moving the decimal 3 over. So 0.027 liters is my liters of sulfuric acid I used in this titration. So I get 0.054 moles of H2SO4, or you could just call it your acid, okay? Whatever way works for you. The second step will always be what we call a mole-to-mole relationship, and this is coming from the balanced chemical equation. So I could take the moles of H2SO4, so 0.054 moles of H2SO4, and I want to know how many moles of the sodium hydroxide I need, or I used essentially, to neutralize it. Okay, so I have to go to my balanced equation. I have a 1 in front of the H2SO4, and I have a 2 in front of the NaOH. So I put a 1 mole of H2SO4 and a 2 mole of the NaOH. So I'm multiplying 2 times 0.054. I get 0.108 moles of my NaOH. Again, you could just call it your base. So the last step is to find the molarity of the base, So I know molarity is moles over liters. So I need to find the moles of base, which I just found. So I'm going to put that there because I know that from the previous calculation. Now I need to know liters of base. So do I have that bit of information? So I go back up to the only bit of information I haven't used is the 41 milliliters. So again, if I want to do 41 milliliters is how many liters is 1,000 milliliters for every liter. Okay, so I divide the 41 by 1,000 and I get 0.041 liters is what I get for the liters there. So if I divide 0.108 moles by the 0.041, I end up with 2.6 molarity as my final answer, So all of these titration problems, you're going to be given an acid and a base, and you're going to be looking for one missing piece of the problem. You always calculate the one that you have 2 bits of information. You take the balanced equation, and then you calculate whatever you're left with, the 2 bits of information to find the molarity. So that's your basics of titrations. That's the basics of your titrations.